Hello.
Yes, sir.
Okay.
Sir,
So
did you upload the slides to the interval and knapsack also, sir?
knapsacks I have uploaded. Uh,
So the
mm,
slides, sir, not the video, sir. The
slides,
slides, sir.
slides I have uploaded for the knapsacks, and the other two will be uploaded very soon. Okay. Now see here. Don't worry about the uploading. Okay, it is my duty. I will upload everything, and you please read the DFS BFS. Now here you see I have drawn a graph. These vertices are the V1, V2, V3, V4, V6, like this V8. Eight vertices are there. So that V is V1, comma V2, like this V8. And edges are these. These are the edges. I have not given the name E1. Say this is E2. Say this is E3 edge. Edge set is also there. So that is E. E is also given. And also some weights are given. Weights on each edge. W. This is basically W. Right. So these are also given. So this is called weighted graph. Now suppose these are the cities. Okay. And you have been told that these are the possible road among the cities. Now you, if anybody asks you that don't create all these roads, don't create all the roads, don't build all the roads, you build few roads, so that the sum of the distance, or these weights may be distance between two cities, say V1 and V3, the distance between them is 20 km. V1 and V6, that is 50 km apart, using this path. Okay. Or if you go like this, 20, then 40, then 32, that is another. Now if it has been asked that you create you build the paths from these edges, so that all the cities are connected by somehow, means there are no isolated cities. Okay, all the cities are connected either directly or via through some other cities, and the sum of the path lengths, okay, of all the roads, sum of the path lengths of the roads is minimized. This is the problem. Now how can we solve this problem? So for this we need spanning tree. This is basically we'll solve it is using a spanning tree. Spanning tree. Spanning tree. We'll found out the minimum weight spanning tree. Minimum weight spanning tree. Now what do we mean by spanning tree in this case? See, this is the graph, this is not the tree. You know that there is a difference between graph and tree. Tree is an acyclic graph, there should not be any cycle, but here you see in this case there are a cycle. So can you tell me what is the difference, means what do you mean by spanning tree of a graph? Anyone? What do you mean by spanning tree of a graph? Guess. At least guess and tell me what can be the spanning tree of a graph.
So like a minimal tree from the
No, no,
graph
no, no,
itself.
no, no. I am not asking about the minimum. I'm just asking the what do you mean by spanning tree of a graph? Any graph that may be
So all
yeah,
the vertices are covered.
yes. See, that means you there may be a graph where no edges, no weights are there. Suppose this is unweighted graph. Still, a spanning tree exists. So, what do you mean by spanning tree? That means you have to create a tree for the graph, so that all the vertices are included in that tree. For example, if anybody says like this, say v7 v this, say v2 in the figure, from the figure v4, say this is v7, is it spanning tree? No, it is a tree but not a spanning tree, because not all the vertices are not included in this set. Clear? So this is not a spanning tree. Now what can be the spanning tree example? In this case it is 5. I can draw like this. You see, for this graph G, for this graph G, okay, I have drawn the spanning tree. So this is basically spanning tree. There are so many spanning tree. Don't think that this is only one spanning tree. Spanning tree of G. Now your friend may do may like this. Say he is connecting this one, say this one, say this one.
Sir, can you please repeat the definitions?
I am saying you construct a tree. You construct a tree from this graph G, so that the tree consists of all the vertices. So that tree consists of all the vertices. You see, in this example, I have drawn two spanning trees. Two spanning trees. You see, either use this pink color or this color to connect all the vertices. There can be another spanning tree. Is it clear now?
Yes, sir. Thank you, sir.
Now you see, the our problem is not to construct the spanning tree, but to construct a spanning tree whose sum of all the weights is minimized. That means there are so many spanning trees. Okay, so here you, which spanning tree will have minimum weight? If you take this, say, suppose if you are taking uh, this one, this one, this one, this one, like this, you will construct. But please remember, there should not be any cycle. Now if you connect means or should you should take a better smaller example. Say suppose this is the graph. This is a graph, and this is v1, v2, v3, v4, and v5, and these are the say 6, 5, 8, 2, 3, 1. Now your friend may construct a spanning tree like this: b1, say b4, suppose this, like this. This is v4, v1, v2, v3, and v5. This is a spanning tree. What is the weight of the spanning tree? Its weight, its weight is how much? I have to compute. See here, its weight is 6, 3, 2, 1. So I have this figure. You see, all the vertices are included. So 6 plus 3, 9, plus 1, 10, plus 2. So its weight is 2, 12. 6, 9, 10, and 12. So now your friend may draw another spanning tree for the same graph G. Yeah, for the same graph G. Now he will get some different weight. So there exist so many spanning trees. Now which spanning tree will give you minimum weight? That is the problem. Okay, so this is the problem. The problem is that you have to compute the spanning tree of a graph or spanning tree of minimum weight for a graph G. Now there are some algorithms. One of the algorithm is known as Prim's algorithm. Prim's algorithm, what it does, you see that you, for example, I'm just taking this example from this. Prim's algorithm selects any node arbitrarily as the root. Any node, okay. Any of these node means vertex. One of the vertex as the root. So here, suppose it is choosing this. So choose any vertex V as root. Okay, you choose any vertex as the root. Clear? Then it has how many outgoing edges? 3 outgoing edges. See, 1, 3, 2. So which one is the minimum? Which edge from the figure? Tell me. Tell me. Which figure is the of minimum weight?
Sir, repeat the question once more, sir.
I am asking that I have chosen V4. Choose step 1. Prim's algorithm says what? You choose any vertex V as the root. So I have chosen V4. In the example, I have chosen V4. So this is the V4 I have chosen. Now it has 3 outgoing edges. So which one is the minimum? Which edge?
V5.
V5.
V5,
So
sir.
you consider this one, V5. Fine. You consider this one and you remove from this I am choosing only this. Now it is 1. Weight is 1. Then how many edges are there? So you see 3, 2, 5, 8. I think. See, actually, I should reduce this. Yeah. Now, fine. So it has one edge 5, another edge is 3, another edge is giving 2, another edge is giving like this 8. So basically it has, see, when you are adding V4, first step you are taking the V4, then you are choosing inserting V5. Why? Because this weight is minimum. Clear? This weight is minimum. Then what you will do after this step? You find out how many edges are outgoing, or outgoing is incoming or incident. I should say how many edges are incident to V4 and V5. Only this set. Check it. But this is not the incident. This edge is not incident. You check. These edge and these edges are not. Only red edges are incident. Check it. Is it clear? V4 and V5. Hello.
Yes, sir. Yes, sir.
So here you see, yes, I have not given the weight here. Let it be say 4. So which one is the minimum? Only among these, I am saying. Only I will consider only the edges. I will consider only those edges which are incident to B4 and B5. Tell me
B4 and
which one
B5.
is. I am considering only these two vertices.
Sir, vertex B3, sir. Sir,
B3, sir.
Vertex
B3.
B3. B3. If you which edge you should say this is an edge V4 V5.
Sir,
V3
B4.
V4 V3. V4 V3. So here I will add this. So that means better I am giving here a tag mark. So this is this is the V4 V3. I am considering this one also. Okay. And please remember, while you connect, means I am inserting here V4 V5, means I am considering the edges here, right? Like this V. Okay, this edges. Means you take a set of edges which are you are adding. Okay, like this edge, this edge, then this edge. Now tell me, this is included. V3 is also included. So here V4, V5, V3 will be included. Which edges are in the next step? Which edges are incident and which is the minimum edge? You consider this set. You consider this set. You see the figure. Which edges are incident? This edge, this edge, this edge, and this edge. So which one is minimum?
Sir, so 1 second. Sir, I guess it's B1, sir.
V1, right? So I will add this next. I will add this one. Okay, I am not writing. I am just drawing the figure. I will add this one, and this edge will be increased. So next figure will be like this. The set of nodes like this. Then after that,
Sir. Sir, it will be V3 to V2, sir.
V3 to V24. Yeah. And the next stage, I will add this one. Clear. Now you see, has it covered all the vertices?
Yes, sir.
Yes. Fine. So what will be the weight of the minimum spanning tree? I am getting what? 1 plus 2 3 plus 3 6 plus 4 10. But please remember one thing very important, that if you what you are doing actually, once you have a set of vertices, then you are choosing which incident edge on those vertices has the minimum weight, and you are including that edge. But while including or inserting that edge, please check by inserting that edge whether it creates a cycle or not. If it creates a cycle, don't insert it, ignore that edge. For example, suppose in this case you told V5, then V4, okay, then V3, then suppose this edge was this edge, I am saying 8, V5 to V3, suppose this edge was of minimum weight among all the others, then if you choose this edge, what will happen? V5, V4, V3, then V5, there will be a cycle. But I am going to find out minimum weight spanning tree. Tree has no cycle. So therefore, you should take care. If the construct means whatever you are generating, whether if it creates a cycle, don't consider it. You consider only the edges if that doesn't create cycle. Is it clear?
Yes, sir.
So this is the Prim's algorithm. So in Prim's algorithm, what happens actually? In Prim's algorithm, see, this is a set S. S contains initially V. Then what you are doing? This set is increasing. Means another, say, V2 you have taken. Then in the next stage, it is further increasing. Say another V3. In the next stage, you are adding, suppose, V4. Then next V5. In this way you are adding. So basically this set S is growing. Okay. So this was the set. The set initially set was 5. Then you took first any random vertex V1. Clear? Then this set is increasing. And as long as then what you are doing actually, see, this set has some outgoing edges. Means whenever there are, these are the sets, so you know there are some outgoing edges. Yeah, so you will so these and the other members of the graph, they are connected here, means they are separate. Clear? So basically what is happening, you see, this is the set S and this is the set V minus S. V minus S means, you know, these are the set of vertices in this set, and these are the set of vertices which are present in V, set of all the vertices but not in S, and there are some edges like this, and also there are some edges that I'm not saying. So what you have to do, you are choosing a minimum weight from this, and this set is increased by taking another vertex from this V minus S. Clear? And whenever this set becomes empty, means null, when it becomes null, means B and S are equals in number of vertices, then we'll stop and we'll report the tree as the minimum spanning tree. Okay, is it clear? Now
Yes, sir. Yes, sir.
can you tell me what is the structure of the structure when you are taking the considering the minimums, means the Prim's algorithm? Always I am getting a tree. Check it. S consists of
Yes, sir.
what? Always I am getting set of vertices and there are some edges connecting that S. All the nodes in S are connected. So always I am getting a tree, subtree. The subtree is increasing. This is called Prim's algorithm. I will upload the slide for it. Now, next you see another algorithm is there that is called Kruskal.
Kruskal.
You know all things. So it is
Sir,
easy repeated.
you taught us a little bit of it during our third semester, sir.
Okay.
Actually.
In Kruskal algorithm, what happens? Say there is a graph. Now, here, what you will do? In this case, so don't worry about the algorithm step by step. I will upload the slide. It contains everything in detail. Also, algorithm time complexity also are decided. Okay. So in this case, you choose the edge having minimum weight. Minimum weight. So I have not given the weights. Say it is 2, 4, 6, 1, 3, 9, 7, 10, 8. This is 7 and this is 1. And this is, okay, this will be suppose this is 12, this is 14. In this way, edges are given. So here you choose the minimum weight. So which one is the minimum? These two, V1, V2. So V1 and V2 will be connected. In the next step, what you will do, you don't consider this one, V1 to V2. Okay, V1 to V2 here. Then you choose, sorry, this is of age, sorry. You take it, say 15. Because if 1 is the minimum weight, then I should consider these two. Na? But here I have chosen V1, V2 because its weight is minimum. 2 is the minimum, suppose. So its weight is, now what we will do in the next, which one is the minimum weight? Tell me. I should give the name. This is the V8. There is no space to write. This is the V8. Can you tell me? Which age is the next minimum after this?
Sir, V4 V8. Sir, V4 V8,
Before
sir.
V8, right? Before V8. So you take like this. This is V4, V8, and so it is 3. And then you add the next minimum weight. Okay, next minimum is 4, I think. So
Yes, sir.
you connect that. So in this way you connect. But if here also you have to check if it creates a cycle. If you add an edge and it creates a cycle, don't add it. You check the other side. And what you are doing, there are so many edges, and you are choosing the minimum of those. Okay, you are finding out, means you find the minimum weighted edges from the remaining. So now here you tell me, means you will get a tree finally. When you will stop, when the number of vertices, now when the number of vertices are become same. So what are the difference between this step and means Kruskal and Prim's algorithm?
Sir, over here we're choosing disjointedly only
Right.
minimum. Like you just
So disjoint means what? That term is, that is called, it is a tree. You are getting two component.
no.
It is no. So that is called forest.
Yes, sir.
Means in each steps you may get a forest. Not necessarily it will be tree, but in that case it will be always tree. Prim's algorithm. And the first step, in the first step you randomly select a vertex in case of Prim's algorithm, but here you are selecting an edge, and after that the both are selecting the edges, but the first step you are selecting vertex. In case of Prim's algorithm, in case of Kruskal algorithm, you are selecting an edge. Is it clear? Then are there any difference? In that case, the set S is the set of vertices. It increases by 1 always. Is it true or not in Prim's algorithm?
Yes, sir. Yes, sir.
Here, in a step, it may not be increased by at all. You check it. First, I have selected the edge having weight 2, means V1, V8, V1, V2. Then V4, V8, fine. A number of vertices is increased. Then I am connecting V2 and V4. When I am connecting V2 and V4, they are already present in this list. Yes, check it. Yes or no?
Yes, sir.
So the set S is not increasing anymore in size, but age is increasing. Yeah, age is increasing. So this is the algorithmically difference. And here you see one interesting problem is there, that you have to find out a minimum weighted age from the remaining one. That is called union find algorithm. That is a part of the union find algorithm. So uh, that you will be included, but you assume that you can assume that you will fetch, there is set of pages, you will fetch that is a black box. You will give a query that find out the minimum weighted age, and it will give you. Otherwise you can implement it using priority queue. What you have to do, find out, you have to find out the minimum weighted age. Fine. So in this case what happens, whenever you are getting means whenever you would like to select the next age of minimum weight, then you will select from the remaining age. So you can maintain a priority queue. Priority queue means mean heap, you know, heap tree. So you can construct and you can fetch the root. Root contains minimum weight. Then again you are next contact in this way. But it each whenever you are fetching the data from the root, means then it needs to be updated. So that takes log n time. So that time complexity etc. will be given. So this is the basic difference of Prim's algorithm and Kruskal algorithm. So I have not shown everything in detail here. In detail you will get. So I will upload the slides also. Don't worry. See, just a minute. I'm just showing. I will upload the slides. Here you see. This is the graph. Can you see it? Hello.
Yes, sir. Yes, sir.
The graph. There are three spanning trees as are shown. Okay. This is the weighted graph total. These are the examples. You see. This is the weighted graph. Then these three. Minimum spanning tree one. The algorithm is shown here. Okay, don't worry. I am I'm seeing just for an example. You have to prove it that it is optimal. Optimality proof is also shown here. You can see this is a greedy based algorithm. It is based. You are expecting that you will get benefit. Why it is greedy? Because at each steps I am choosing which is the minimum, local minimum. Am I sure? Hello?
Yes, sir.
You see? So the local minimum I am choosing, and finally I am getting global minimum. But it is not always the case. In this case, we are getting. So this is greedy based algorithm. If anybody asks you that minimum spanning tree Prim's algorithm, is it greedy? Yes. It is based on which technique? Then you should say it is greedy based technique. Also the Kruskal, same. Yeah. Here in this case, you see that you randomly select one node as a root. Okay, then which one is the minimum from it? A to B. Check it. A to B. Clear? Then which one? A, B, C, 8, 9, 8, 10. So any of the 8. Say A, B, D. Okay. Then which age will be selected? Tell me. After this. Here you see. These
Sir,
three, na?
ABDC.
A, B, D, C. Then
Sir, ABDCF.
next.
ABDCFG. Um, ABDCFGE. Done.
FGE or FEG. Means F2E or G2E.
Oh, sorry. FEG. Sorry. FEG, sir.
Clear? So in this way, you have computed and it will take means using that heap I told you, create the final algorithm, and it will take this much amount of time. So don't forget about the Fibonacci heap. I'm not going to advanced. So up to just E log V. Okay, you check up to this. I will upload it. I'll upload. Similarly, Kruskal algorithm is also there. I have discussed everything. Just correctness proof is very important. I am saying greedy algorithms are very easy to design. Okay, greedy algorithms are very easy to design, but its correctness proof is very, means it's not trivial. So please take care of all this. I will upload the slides also. You read this and